tornadoes.
We've seen the videos on TV or through videos on the internet. Rotating walls of flying dust and debris with wind strong enough to rip a house to shreds. But how does one form, and how do we determine its intensity? But the most important question,
What in the wide world of weather is a tornado?
well, according to the Amos glossary of meteorology, a tornado is
A rotating column of air in contact with the surface, pendant or hanging from a cumuloniform or cumulus-like cloud, and often visible as a funnel cloud and or circulating dust or debris at the ground.
The key phrase here is at the ground. A tornado cannot be called a tornado unless the funnel cloud is actually in contact with the ground.
This confuses a lot of people. If the column of air never reaches the ground but still has debris in rotation, it is simply a funnel cloud. We make this distinction because when the funnel cloud interacts with humans in the built environment on the ground, it causes the most damage.
So, how the tornado formed? Well, we really don't know the details yet.
There are a great number of things we do know about tornado genesis, or the birth of a tornado, but many of the small-scale nuances are still yet to be uncovered with further research. What we do know is that the most devastating tornadoes are the ones that form within massive supercells, which are rotating thunderstorms. Many of these supercell structures are accompanied by a well-defined, low-level circulation called a mesocyclone. Yet there are other thunderstorm types that also produce tornadoes like squall lines and bow echoes.
So what gives? Why do thunderstorms form from many different thunderstorm structures, yet we know so little about their genesis, and yet they're such a common occurrence in the United States?
It's mostly because, relative to larger weather phenomena like hurricanes or blizzards, tornadoes are actually very small in comparison. This is why storm chasers who have legitimate research objectives are valuable to the weather community. They attempt to collect data and observations from the near storm environment, which, as you might imagine, is extremely dangerous because the winds in the tornado can pick up a car and toss it around like a toy. We need these in situ observations to understand the subtle differences from one tornado formation to another.
Now, major progress has been made in the past couple of decades thanks to phased array radars and Doppler-on-wheel observation tools, giving us a look at the guts of a tornado to diagnose its thermodynamics and its structure.
For many years, the United States did not record any annual tornado fatalities, but unfortunately that all came to an end in 2011 with a massive super outbreak of tornadoes in Dixie Alley. Sadly, over 300 people lost their lives on this deadly day, showing forecasters and policymakers that more work is needed to be done in giving the public a much longer lead time to get in a safe location. There are projects out there such as the Pekin Project, which stands for the Plains Elevated Convection at Night, where atmospheric scientists are attempting to gather more data on the various factors that influence tornado formation. With work like this and other projects, scientists hope to increase the lead time, communicate the risk of tornadoes, and ultimately save more lives from this incredibly hazardous and harrowing weather phenomenon. Now, when a threat for tornadoes, or severe weather in general, takes shape over an area, the Storm Prediction Center in Norman, Oklahoma will closely monitor the situation and, if there is enough ingredients present, either issue a severe thunderstorm watch or tornado watch. A severe thunderstorm watch just basically means that there is a greater chance for severe thunderstorms within that area.
Just because there's a severe thunderstorm watch over an area does not mean that area will see any tornadoes. Tornadoes are considered a part of severe weather. A tornado watch, on the other hand, basically just means that there's a greater chance for tornadoes within that area.
Now this is where your local National Weather Service office comes into play. Using their next-rad Doppler radars, which are some of the most advanced radars in the entire world, they constantly monitor every scan they receive, looking for tornado signatures like the hook echo or the velocity couplet. During this time, the National Weather Service will also be taking calls from trained storm spotters. Once they see these tornado signatures or have a trained storm spotter see a tornado, they will immediately issue a tornado warning for that area and the potential path of the storm and, if need be, extend the warning. So when a tornado touches down and causes damage to an area, how do we know its strength when the tornado was, usually, never seen or directly measured? In this case, the National Weather Service must determine whether or not the damage was actually caused by a tornado. This may seem dumb, but there are many instances where quote-unquote tornado damage can actually be explained by strong straight-line winds.
Straight lines. Let's bring back that definition of a tornado. Ah, thank you, future me. Notice how it says a rotating column of air. See, this is what the National Weather Service surveyors are looking for when looking for tornado damage.
Take a look at this photo. There's one thing that generally stands out to me. And it's the direction where all these downed trees are pointing. They're basically pointing and converging at the spot on top of the picture. Now follow the arrows around. You have basically a spiral. This is the rotation that the National Weather Service is looking for when determining whether or not a tornado struck or not. So now we know that there was indeed a tornado that struck and caused damage. The next step is to figure out the intensity of the tornado. This can be really hard to do because there are different buildings and trees that can be taken out with either stronger or weaker winds, especially with buildings, as there are many different types of houses and structures, and some of those buildings may have not been constructed correctly, causing them to be more prone to weaker tornadoes. After figuring out what it takes to bring down the structures within an area, we can finally figure out the tornado's intensity using the handy-dandy Enhanced Fujita Scale! Named after Dr. Tetsuya Theodore Fujita, who developed the original Fujita scale, this updated version of the scale takes the estimated wind speeds from the National Weather Service surveys and categorizes them into 6 tiers, ranging from EF0, around 65 miles an hour, to EF5, which is over 200 miles an hour, along with giving the tornado's width and damage path length. Tornado Fast Facts. The safest place to seek shelter from a tornado is the most interior room on the lowest floor of the building, away from windows, preferably the basement. If you are outside with nowhere else to seek shelter, lie as flat as you can in a ditch with your hands covering your head and neck. The longest damage path caused by a single tornado is the Tri-State tornado on March 18th, 1925, with a damage path of 219 miles while staying on the ground for nearly 3.5 hours. This tornado is also the deadliest in the United States, as 695 people over 3 states, hence its name, lost their lives. The strongest recorded winds in the entire world came from the May 3rd, 1999 Moore, Oklahoma tornado at 301 miles per hour, thanks to a Doppler on wheels located near the tornado. The widest tornado is the May 31st, 2011 El Reno, Oklahoma tornado with a width of 2.6 miles at its peak. Just because a tornado has already hit an area in the past does not mean another won't hit again, just as the people of Oklahoma City, Moore, Oklahoma, and Xenia, Ohio, who have all been hit by multiple tornadoes.
And that does it for this episode of What in the Wide World of Weather. Join me next time as I will be taking a look at when weather meets space in the Aurora Borealis. And remember, the more you know about weather, the better prepared you can be when it strikes.